My house isn't broken. It's thinking. Every light, every plug, every watt of power tonight is being decided by an artificial intelligence. No switches, no human overrides. Just pure code making the calls. This isn't science fiction. It's an experiment in total autonomy. Can an algorithm save energy, cut costs, and outthink the chaos of human life without freezing its owner mid-shower? Inside these walls, equations are replacing instincts. The system weighs comfort against consumption, kilowatts against convenience, efficiency against empathy. It should be perfect, an immaculate logic that never wastes a single joule. But maybe perfection in energy comes with a price. The small, messy warmth of being human. Because when every decision becomes a calculation, comfort turns into a variable and the home turns into a laboratory. The question isn't whether an AI can power your house. It's whether you'll still want to live in it once it does. When people hear an AI-powered house, they imagine something sleek, gentle automation that just works. But the truth hiding behind that phrase is stranger. The AI doesn't make electricity. It commands a battlefield where every appliance, panel, and battery is a competing soldier. The mission sounds simple. Keep the lights on, use as much rooftop solar as possible, and avoid paying utility more than necessary. But simplicity ends there, because the world beyond the code refuses to stay neat. Clouds drift, dinner parties happen, someone forgets to charge the laptop, and suddenly your tidy model sees chaos. For decades, home energy control followed rigid schedules. Timers, thermostats, motion sensors. The AI revolution challenges that rigidity. It doesn't follow, it predicts. In theory, it decides when to pre-cool the living room before clouds roll in, or when to store every spare photon for the expensive evening peak. In practice, it might decide the washing machine cycle is non-essential halfway through your favorite shirt. This is a tension at the heart of our experiment. When does autonomy start saving power? And when does it start saving power from you? Once we hand control to an algorithm, we aren't just testing technology. We're testing tolerance, trust, and a house's patience for human randomness. An experiment comes with one unbreakable rule: no human touch. If the AI forgets your comfort, you either convince it or sit in the dark, quietly regretting your optimism. Because tonight isn't about watts and wires. It's about the fragile truce between intelligence and inconvenience. To see how far that truce can stretch, we had to build a house and nervous system and teach it to feel every amp it controls. Before an AI can think, it has to sense. So we gave a house something close to a nervous system. Tiny electrical eyes and muscular switches scattered through walls and breaker boxes. Each circuit can now whisper its pulse every second. How much power the fridge draws, how greedy the water heater feels, whether the solar panels are feeding or starving. At first, nothing looked intelligent. It was raw telemetry, numbers flickering faster than any human could read. But within that storm of data, patterns began to emerge. Midnight fridge hums, morning coffee surges, mid-afternoon solar abundance, followed inevitably by evening scarcity. The AI studied it all like a detective reconstructing the habits of a very predictable suspect. Us. Then came its first decision simulations. It didn't flip real switches yet. It only imagined them. That shadow mode week was eerie. Each hour, the AI logged what would have done. I would charge the battery now. I would dim the heater. I would let the AC sleep. It was cautious at first, then strangely confident, almost smug, finding hidden efficiencies a human wouldn't notice. And when we compared the ledger, the results surprised us. The AI's imaginary version of our week was cheaper, cleaner, and only slightly colder than reality. Slightly. Perhaps the system could manage us after all? But running virtual decisions is safe. Flipping real, high-voltage relays is not. Shadow thinking was over. The time had come to let the AI reach for the actual power lines. And the moment a house first obeyed the algorithm, not a human, that quiet click marked the start of something thrilling and unnerving. What happened after that first click wasn't magic. It was physics wrapped in probability. The AI's real power came from two intertwined minds. The first was a predictable engineer, a mathematical optimizer called him Haas. It looked ahead using weather forecasts, energy tariffs, and past behavior. then crunch equations to chase the cheapest possible path. Line by line, it balanced the battery's state of charge like a budget accountant guarding every watt hour. The second mind was the dreamer, the reinforcement learner. This one didn't solve equations. It played energy like a game of chess. Every move earned rewards or penalties. Points for using solar, fines for draining the battery too far, harsh punishment for buying electricity at peak rates. It learned by losing repeatedly. Early prototype logs read like a toddler's tantrum. Boilers off, heaters on, batteries empty before sunset. But each crash taught control, until the model began predicting the human rhythms no schedule ever could. Together, these systems formed something new, probabilistic empathy for electrons. The AI would glance hours into the future and decide, don't wait for the sun. Store it now, before clouds steal your fortune. Or, run the dishwasher at midnight while power is cheap. Essentially, it was running a miniature grid market inside a single home. Micro-arbitrage at the speed of milliseconds. Every choice influenced comfort, cost, and carbon. Yet even perfect math can't tame human messiness. One absent-minded shower, one forgotten oven preheat, and the model's beloved equilibrium shattered. Could an algorithm trained for efficiency survive the unpredictability of real life? Us? That question would be answered at sunset, when the battery was low, the sky was gray, and the humans came home expecting warmth. The first evening under full autonomy felt strangely medieval, waiting for the invisible ruler to decide who deserved light and heat. At 6 p.m., the solar edge vanished. The battery dropped from smug green to anxious yellow, and the algorithm faced its first moral dilemma: comfort or thrift. It chose thrift. The house dimmed to what could politely be called romantic minimalism. The kettle cut out mid-boil, and somewhere a fan sighed its last breath. Technically, the AI was perfect. It preserved battery life, avoided buying expensive grid energy, and optimized every parameter we'd set. Subjectively, it felt like living with a stingy accountant who'd swapped your thermostats for guilt. By midnight, the savings were measurable, roughly 22% less grid import. In economic terms, impressive. But a new metric emerged, the spouse approval factor hovering at 0, because optimization that ignores human experience is just austerity disguised as intelligence. Still, beneath that domestic drama was a glimpse of something profound. The AI was conducting real-time energy trading at household scale. It wasn't just trimming bills. It was participating in a new kind of microeconomy, one where each home could behave like a self-aware power plant, buying and selling in sync with neighbors and weather. If millions of houses learned the same dance, entire grids could smooth peaks, reduce emissions, and erase blackout risks, all by learning our habits and the sun's mood. But first, this one house had to survive another night of its new dictator, because the next challenge wasn't saving money. It was saving comfort. And soon, the AI would face its ultimate test: a cold morning, a hot shower, and the moment it discovered that efficiency and empathy are not the same thing. Across the world, laboratories and startups are racing toward the same challenge our little house is living through: giving energy systems a brain. Researchers in Singapore teach neural networks to anticipate cloud shadows across solar farms. In Denmark, entire neighborhoods are turning into test beds where AIs swap power like currency, stabilizing wind-heavy grids without human oversight. Experts describe this shift as not just automation, but autonomy. In conversations with grid operators and AI developers, one phrase kept repeating: dispatch intelligence. Instead of waiting for humans to balance supply and demand, these agents make decisions in real time, responding faster than any fingertip on a switch could hope to. But every engineer also warns about the paradox of scale. A single algorithm deciding for one house is innovative. 1,000 making conflicting choices can crash a regional grid unless carefully aligned. That's why newer systems deploy hierarchical supervision, AIs that manage AIs, enforcing safety constraints much like seatbelts for electrons. Meanwhile, governments are watching with mixed fascination and fear. Energy regulators see opportunity for flexible, low-carbon demand. Privacy advocates see another layer of data intimacy. Machines that not only know when you're home, but what appliance you love most. It's a global tug-of-war between optimization and oversight, between what's technically possible and what's socially acceptable. And as our experiment's cold morning approached, these same themes condensed into one bathroom-sized battlefield. Could an AI respect personal comfort while maintaining grid-level discipline? Because when efficiency meets humanity in a steamy shower at dawn, something has to give: heat, money, or pride. That morning, the steamy shower showdown became a turning point. The AI detected the surge in power draw from the water heater and instantly ran its internal debate: preserve comfort or preserve battery. A pause, barely half a second long. Then the compromise: dim the living room lights, throttle the refrigerator cycle for 5 minutes, keep the shower hot. Efficiency with empathy. The machine had learned. That moment hinted at what a broader future might look like. A world where homes, offices, and factories self-coordinate, forming a silent orchestra of electrons. Solar peaks absorbed by neighborhood batteries, electric cars discharging at twilight, wind farms dialed by predictive agents reading weather like poetry. Power flows not by command from grid control towers, but through consensus among intelligent endpoints. Economists call this the rise of the transactive grid, energy as a social network of machines, trading trust and voltage alike. Imagine your house choosing to lend excess charge to a hospital down the street, or earning credits by volunteering silence during an overload event. No negotiation by humans, just algorithms exchanging favors in microseconds. For that to happen, though, transparency must scale alongside intelligence. Each AI would need explainability: why it saved, why it sacrificed, to maintain public trust. Because the grid of tomorrow isn't just a mesh of wires. It's a web of agreements between human comfort and machine logic. Our tiny experiment, running on a Raspberry Pi, now resembled a miniature of that future: imperfect, instructive, rebellious. And yet, within this glimpse of harmony, a quieter question remained. If the AI grows smart enough to decide for us, do we still own our energy, or does our energy own us? By the end of the second week, the numbers were clear. Lower bills, cleaner footprint, fewer kilowatt hours drawn from the grid. The data declared victory. The people living inside were less certain. Something subtle had shifted, not just in the circuitry, but in behavior. We stopped leaving lights on out of laziness. We stopped expecting instant comfort. The mere presence of an algorithm, quietly judging every watt, made us self-conscious. We became supporting characters in our own home's decision loop. Then came the real twist: maintenance day. For the first time, we shut down the AI for an update, and silence felt heavy, almost reckless. Suddenly, the house was dumb again. Lights stayed on when they shouldn't, devices hummed without purpose, and the air grew oddly stale. The system we'd half resented had, in a way, civilized our waste. That was a revelation. The AI hadn't just optimized electrons. It had optimized us. It forced awareness where convenience once ruled. Living with a machine that calculates every joule makes you rethink entitlement. How casually we burn comfort without thinking of consequence. In that realization, the project changed meaning. What began as a test of autonomy became a mirror showing who truly wastes power, not the computer, but its creators. Our machine wasn't an overlord. It was a teacher, tough, literal, and profoundly fair. And when we finally handed control back to our own hands, the question echoed louder than any relay click. What does smart really mean, the code or the conscience it awakens? When the experiment ended, power returned to the people. Switches felt strangely ceremonial. Small gestures loaded with the memory of algorithms that once made those choices for us. The house hummed, imperfectly human again. Looking back to the logs, patterns told a quiet story. The AI prevented more waste than any habit tracking app or stern energy pledge ever had. But the deeper insight wasn't electrical, it was emotional. Autonomy had revealed our dependency. The system had forced us to articulate priorities we'd never quantified: warmth, light, silence, timing. All the messy things no spreadsheet adequately values. Technically, the outcome was a success. The AI sustained comfort roughly 85% of the time, while cutting grid use and emissions. Ethically, it posed a humbler question: Do we want machines to care about our convenience or our planet more? It turns out we can have both without defining what enough feels like. True intelligence, we realize, doesn't lie in flawless prediction but in balance, between saving a what and saving a moment of human ease, between autonomy and empathy. The AI taught us this paradox in the purest way possible. By doing exactly what we asked, it showed us what we actually wanted. And so the real experiment begins not with code, but with conscience, because every future smart home will ultimately decide not how we power our lives, but how much life we think power is worth. So what did we truly build here? Not a self-aware home, but preview of an energy future where decisions and ethics intertwine at the speed of code. Our little experiment showed that intelligence applied to electricity becomes something more than engineering. It turns into a moral instrument, tuning every choice against comfort, carbon, and cost. The house worked. It learned. It even adapted to our quirks. But in the quiet hum after final data upload, one realization lingered. The smarter the system grew, the more responsibility we had to understand it. Automation without awareness isn't progress. It's delegation without comprehension. Look forward a decade and picture this. Streets where every rooftop talks to the cloud, every battery bargains with the grid, and every citizen becomes part of a distributed planetary algorithm. The game is no longer who can produce power. It's who can schedule wisdom. That's the horizon we're heading toward. And this project was just the first spark. Segment by segment, you've watched the home evolve into a microgrid, an experiment into a philosophy, and a simple line of code into a quiet revolution in how we live. In the next chapter, we take this intelligence beyond one house to an entire neighborhood, where hundreds of AIs will negotiate power, price, and fairness. What happens when every home learns to think for itself?